ఈ వీడియోలో we are going to discuss two important topics from acids, bases and salts chapter. ఆ టాపిక్స్ ఏంటంటే కెమికల్స్ ఫ్రమ్ కామన్ సాల్ట్ అండ్ వాటర్ ఆఫ్ క్రిస్టలైజేషన్ ఆర్ రిమూవల్ ఆఫ్ వాటర్ ఆఫ్ క్రిస్టలైజేషన్. ఓకే, సో ఈ వీడియో చివరి వరకు చూడండి సో దాట్ యూ విల్ అండర్స్టాండ్ దీస్ టూ కాన్సెప్ట్స్ వెల్. Salts are ionic compounds and they are produced by neutralization reaction. మనం ఇంతకుముందు నేర్చుకున్నాం acids when they react with bases you are going to get salts and water, right? Salts అనేవి ionic compounds. For example, NaCl is a salt, right? It has got two ions, Na plus and Cl minus. ఇలా మీరు డిఫరెంట్ సాల్ట్స్ ఏవి చూసినా కానీ they'll have ions. That's why they are ionic compounds and they are produced by neutralization reaction. They are electrically neutral. అంటే ఇక్కడ Na ప్లస్ ఉంది కదా, ఇక్కడ Cl మైనస్ ఉంది కదా, అంటే ఒక ప్లస్ అయాన్ ఉంటే కనుక ఒక నెగిటివ్ అయాన్ ఉంటుంది, టూ పాజిటివ్ అయాన్స్ ఉంటే కనుక టూ నెగిటివ్ అయాన్స్ ఉంటాయి. ఓకే, ఆర్ అదర్వైజ్ ఫర్ ఎగ్జాంపుల్ Na2SO4 ఉంది, రైట్? సో యూ హ్యావ్ two Na plus ions but one SO4 2 minus ion. దీని చార్జ్ చూడండి 2 మైనస్, దీని చార్జ్ చూడండి 2 times plus 1, right? So for that reason these salts are electrically neutral. అంటే they don't carry any charge, పాజిటివ్ చార్జ్ కానీ నెగిటివ్ చార్జ్ కానీ ఉండదు. They are charge neutral. Please note this. Sodium chloride is one of the widely used salts in our daily life. We all know, right? This is called common salt. Salt crystals ఉంటాయి కదా, we use that for various applications. It is abundant in nature and found vastly in salt mines and sea water. Sea water లో జనరల్గా మేజర్గా దొరికేది sodium chloride salt. Okay, there will be other salts also, but sodium chloride is one of the major salts available in sea water. So for that reason you can say that it is abundant in nature. It is used in food preparation, మనం టేస్ట్ కోసం యూజ్ చేస్తాం, and food preservation. For example, certain pickles లో వాటిలో we use sodium chloride as a common salt to preserve the food. For example, if you want to preserve some chicken or something like that, people mix some amount of salt and put it in deep freezer, right? That's how you can preserve. It may be affecting the bacterial growth or something like that. Okay, so it is also vital for various bodily functions. For example, sodium chloride intake తక్కువైతే కనుక we'll have some problems. Okay, ఎక్కువైనా కూడా there are problems. Okay, so it is vital for various bodily functions. Not only in humans, it is in animals also. Sodium chloride balance is important. It is an important raw material for production of various chemicals. Please note this. The chemicals we are going to discuss are sodium hydroxide, baking soda, washing soda and bleaching powder. For all these chemicals we can use sodium chloride as the raw material. Okay, now let's learn about how sodium hydroxide is made from sodium chloride. Sodium hydroxide is made from common salt using electrolysis process. Please note this. Electrolysis process use chesi sodium hydroxide is made from common salt. Sodium hydroxide చూస్తే కనుక you have white color flakes లా ఉంటుంది and చాలా soapy feel తో ఉంటుంది. What we do is, to prepare sodium hydroxide, we first prepare brine solution, that is 5% NaCl in water. Okay, you take 1 liter of water and add 5 grams of sodium chloride. So that kind of solution is called brine solution. That is used as raw material. So NaOH electrolysis process use chesi NaOH prepare cheyalante what is the raw material? Brine solution that has got 5% NaCl in water. Then into that solution, you pass electricity. When electricity is passed through this solution, it decomposes to form NaOH. The other products formed in this process are chlorine gas and hydrogen gas. మనం కెమికల్ ఈక్వేషన్ రాసామనుకోండి ఈ పర్టికులర్ ప్రాసెస్కి, వాట్ హ్యాపెన్స్ ఈజ్ యూ హ్యావ్ 2 NaCl and water, meaning brine is the input and you are passing electricity such that you have NaOH formed and Cl2 gas formed, that is chlorine gas, and hydrogen gas formed, right? So NaOH is the main product and these two are byproducts. This process is also called chlor-alkali process. దీని chlor-alkali process అని ఎందుకు అంటున్నాం అంటే, we are getting chlorine as one of the outputs and NaOH, that is also called alkali. NaOH అనేది base అని తెలుసు మనకి, right? Sodium hydroxide is a base. And since it dissolves in water, we call that as alkali. Please note this. Alkali ante it is a base. At the same time, it is dissolved. It can be dissolved in water. అర్థమైందా? అందు గురించి this process is called chlor-alkali process. NaOH is also called caustic soda. Okay? Caustic ante it is very corrosive in nature and meaning. So NaOH is a soda which is very corrosive. That's why it is popularly known as caustic soda. It is used in making of soaps, detergents, and paper, etc. You know, various manufacturing process lo caustic soda ni vaadtaru. Soaps, detergents, paper making, and sometimes to degrease metals. For example, grease undi, metal kantukupoyi undi. If you want to degrease that, okay, caustic soda is used. Chlorine, one of the products of this process, is used in water treatment, right? Swimming pools lo vaadtam. And making of PVC, polyvinyl chloride annam, right? There is a chloride in this molecule. Polyvinyl chloride lo chloride undi kada, so that comes from chlorine. And bleaching powder, pesticides, ఇలాంటివన్నీ తయారు చేయడంలో chlorine is used. Okay, it is also very corrosive gas. Then we have hydrogen. Hydrogen is used as fuel. Okay, hydrogen is used as fuel. Now people are talking about hydrogen based cars and all. And it is also an important raw material for ammonia production. Ammonia అనేది one of the crucial fertilizers. ఓకే, సో దాన్ని ప్రొడ్యూస్ చేయడానికి హైడ్రోజన్ గ్యాస్ అనేది వాడతారు. సో వీ సెడ్ దట్ బ్రైన్ సొల్యూషన్ ఈజ్ యూజ్డ్ యాజ్ రా మెటీరియల్స్ టు మేక్ సోడియం హైడ్రాక్సైడ్ అండ్ వీఆర్ గోయింగ్ టు పాస్ ఎలక్ట్రిసిటీ త్రూ ద బ్రైన్ సొల్యూషన్, రైట్? ద ఎలక్ట్రోలైజర్ can be shown like this. You see here, this device is called electrolyzer. You have two electrodes, anode and cathode. Okay, you will be connecting a battery between these two electrodes so that the power or the current is going to pass. Okay, now when the current is passing from one electrode to the other or from the battery to these electrodes, actually this has to connect so that the circuit completes and the current passes, right? If the current has to pass, then the circuit has to complete. Circuit manam inta mundu we discussed, sodium chloride solution, acid, dilute acidic solutions, dilute basic solutions. They are going to pass the current, right? Enduku they have ions in it and those ions are going to help the circuit to complete. Okay, in this case you have Na plus ions and Cl minus ions, right? Brine has got Na plus ions and Cl minus ions. So when you pass the current from the battery to these two electrodes, the circuit completes because Na plus ions will be moving towards cathode. Cathode is negatively charged electrode, right? Na plus ions will go this way and chloride ions will be moving towards the anode. Okay, negatively charged chloride ions move towards positive electrode, and positively charged ions will move towards cathode. Okay, now what happens is, you are having more amount of chlorine in this portion, right? So these chloride ions join together to form chlorine gas and they leave this chamber. Okay, similarly, these Na plus ions are moving this side and they interact or react with OH minus ions available at the cathode and they form NaOH. That dilute NaOH solution leaves the chamber from this side. And what is extra is actually you have H plus ions, because some OH minus ions already took part in the reaction to form NaOH, right? Meaning there are some excess H plus ions, they join together to form hydrogen gas and that gas leaves from this side. Understood? Chlorine gas is formed in the electrolyzer near the anode. Please note this, chloride ion minus charge it has got. So if chlorine gas has to form, it has to form at the positive electrode, that is called anode. Please note this. And hydrogen gas, that is H2, that's a combination of two H plus ions plus electrons. Electrons are given by the current flowing through the circuit, right? So H2 gas gets formed near the cathode, which is a negatively charged electrode, right? So hydrogen gas is formed in the electrolyzer near the cathode. And NaOH solution is also going to get formed near the cathode. Please note this. Okay, these points may come as bit questions actually. This is important to remember. Understood how NaOH solution is prepared in the electrolyzer with the help of brine solution, 5% NaCl solution. Just by passing electricity through it, you are going to get products like NaOH, chlorine gas and hydrogen gas, right? Let us now learn about preparation of bleaching powder. We have seen that chlorine is one of the products of electrolysis of brine, right? And a 5% NaCl solution on the other than brine and brine solution, when you pass electricity through it, you're going to get NaOH as one of the products and chlorine gas as another product, right? That chlorine can be used to manufacture bleaching powder. Bleaching powder is produced by chlorination of slaked lime. Slaked lime ante CaOH twice, right? That slaked lime, when it reacts with chlorine gas, it is going to give you bleaching powder. CaOH twice plus Cl2 giving rise to bleaching powder, that is CaOCl2 plus water H2O. This reaction is conducted in this kind of equipment. You have different chambers and every chamber has got a rotary mixer kind of thing. Okay, and the slaked lime is entering from the top and chlorine gas is entering from the bottom. Now these rotors are rotating such that this slaked lime, that is like a slurry, is well mixed with chlorine gas so that this reaction happens. When this reaction happens, you are getting CaOCl2 plus water as the products, right? That start leaving from the bottom of the equipment. So this is a typical process. Bleaching powder is white to light yellowish in color. You see, this is the bleaching powder. It is in light yellowish color, right? Sometimes it can be even white. It is used in textile industry to bleach cotton and linen. In paper industry to bleach pulp. Bleach చేయడం ద్వారా ఏంటంటే you are removing certain colors. ఓకే, పల్ప్, పేపర్ పల్ప్ ఉంది కదా, పేపర్ పల్ప్ డర్టీ కలర్లో ఉందనుకోండి, బ్లీచింగ్ వాడడం ద్వారా యూ ఆర్ గోయింగ్ టు బ్రింగ్ ఇట్ టు నియర్ వైట్ కలర్. సేమ్ ఈజ్ ట్రూ విత్ ఈవెన్ టెక్స్టైల్. You are bleaching the cotton means you are making it look more white. It is also used as oxidizing agent in many chemical industries. Please note this. It is used in water treatment to make the water free of germs. Right? స్విమ్మింగ్ పూల్స్లో వాడతారు, ఎందుకంటే జర్మ్స్ లాంటివి గ్రో అవ్వకుండా క్లోరిన్ గ్యాస్ పంపిస్తే ఇట్ కెన్ కిల్ those germs such that the water is maintained in a usual condition. Understood how bleaching powder is prepared? Now let's look at baking soda. How baking soda is made, that is also called sodium bicarbonate. When ammonia, carbon dioxide are introduced into brine solution, the reaction occurs to form sodium bicarbonate. Please note this. Sodium bicarbonate raw materials enti? Brine solution and carbon dioxide and ammonia, right? Sodium chloride and water, this is put together is your brine solution. Another reactant is CO2 and another reactant is ammonia. When these are mixed, you're getting sodium bicarbonate and ammonium chloride. Okay? Baking soda is a white crystalline powder. Please take a look at this. This is white crystalline powder. This is called baking soda. It is used as a household cleaning agent. మనం కెమికల్స్ వాడకుండా పెస్ట్ కంట్రోల్ చేద్దాం అనుకున్నాం అనుకోండి, అంటే ఇన్సెక్టిసైడ్స్ కానీ పెస్టిసైడ్స్ కానీ అలాంటి కెమికల్స్ వాడకుండా ఫుడ్ గ్రేడ్ మెటీరియల్తో పెస్ట్ కంట్రోల్ చేయాలన్నా కానీ యూ కెన్ యూజ్ బేకింగ్ సోడా. ఓకే, this is a household cleaning agent. It is a mild non-corrosive base. Please note this. It is a basic material, meaning its pH is greater than 7, and it is a mild non-corrosive material. Please note this. It is also an ingredient in antacids. Sodium bicarbonate is used to make antacid tablets and things like that. It also acts as mild antiseptic. ఏదైనా దెబ్బ తగిలితే కనుక యూ కెన్ యూజ్ సోడియం బైకార్బోనేట్ యాజ్ అన్ యాంటీసెప్టిక్ ఆల్సో. అఫ్ కోర్స్ ఇట్ ఈస్ నాట్ ప్రిఫర్డ్, బట్ if proper medicine is not available, you can make use of it. Baking powder is different from baking soda. Please note this. The baking powder, which is used for cooking and baking, contains sodium bicarbonate and calcium dihydrogen phosphate and starch. Okay, these are two extra ingredients other than baking soda. When you have these three together, it is called baking powder. Please note this. Baking powder is used in cooking and baking. Of course, one can use even sodium bicarbonate also, but it is not used. The baking powder is used. Baking powder has got two more other chemicals. How it works is, actually when you heat the food product which has got, for example, you are using baking powder for baking some cakes or breads, let's say. While mixing the dough or while preparing the dough, you are going to add some amount of baking powder to it, right? It has got NaHCO3. When you heat the food, the dough, NaHCO3 is going to release CO2. That CO2 has to come out of this dough, right? When it is coming out of the dough, it is going to make some pores. Okay, those pores make the bread and cakes look spongy. Understood how baking powder works? This sodium bicarbonate is something which is responsible for it. When you heat the product, sodium bicarbonate is going to release CO2, and that released CO2 has to escape out of the dough, right? When it is trying to escape out, it is going to form some porous structure within the dough, and that results in spongy cakes. Soft ga unna feeling vastundi, right? That is why you are getting it. This is the equation for that. You have 2 NaHCO3. When you heat it, you are getting sodium carbonate. This is called sodium carbonate. Please note this. Na2CO3 plus H2O plus CO2. This CO2 is responsible for getting breads and cakes spongy, right? In this process, we are getting another chemical that is called sodium carbonate. Now let's learn about sodium carbonate, how to prepare sodium carbonate. It is also called washing soda. Sodium chloride is the raw material for making washing soda. Of course, sodium bicarbonate is also a raw material, right? By heating it, you are getting sodium carbonate or washing soda, right? So sodium chloride is the raw material for sodium bicarbonate. For that reason, you say that sodium chloride is the raw material for making washing soda. Washing soda has got sodium carbonate, Na2CO3 and 10H2O. Please note this. These 10H2O molecules are sort of binding to Na2CO3 such that it exists as one material. Okay, so formula for washing soda is sodium carbonate 10H2O. When baking soda is heated, we have seen that CO2 gets released to form sodium carbonate, right? When Na2CO3 forms, it absorbs moisture from the surroundings to form washing soda. 2NaHCO3, when heated, we are getting Na2CO3 plus H2O plus CO2, right? The CO2 gas leaves and you have Na2CO3 and H2O, right? It means you have solution of Na2CO3 in water, right? So what happens is this Na2CO3 and this H2O together is going to form Na2CO3 10H2O, and that is called washing soda. Please note this. This process is called recrystallization of sodium carbonate. You have sodium carbonate and it is forming crystals along with water. Sodium carbonate looks like this. This is a crystalline material. You have got water also along with Na2CO3. When this solution is cooled, we have said that this is getting formed, right? When the reaction happens, CO2 is getting released and Na2CO3 plus H2O remains in the vessel, let's say, reaction vessel. And when this solution cooled, the crystals of washing soda are going to form. What are those crystals? Sodium carbonate decahydrate, ante Na2CO3 10H2O. So these are the crystals of washing soda. Understood? This process is called recrystallization. And this water is called water of crystallization. Please note this. So Na2CO3 plus 10H2O is going to give you washing soda, that is Na2CO3 10H2O. Understood? Washing soda is used in glass, soap and paper industries. Please note this. It is also used in water treatment, making of cleaning agents and laundry detergents. Please note this. Washing soda has got multiple uses. Glass, soap and paper industries, they use washing soda, and it is also used in water treatment, making of cleaning agents and laundry detergents. Got it? Let us now learn about removing water of crystallization. We just discussed that sodium carbonate has got water of crystallization, right? So similarly, many crystalline compounds contain water molecules within their crystal structure. These water molecules are called water of crystallization. For example, we have seen washing soda that it has 10 water molecules, right? That's why it is called sodium carbonate decahydrate. It looks like this. And other salts, other crystalline compounds that has got water molecules within their crystal structure are gypsum. This is called calcium sulfate dihydrate, meaning 2 water molecules are there along with calcium sulfate. Gypsum looks like this. Plaster of Paris, that is called calcium sulfate hemihydrate, meaning you have CaSO4 and half H2O. So plaster of Paris looks like a powder, white color powder. And copper sulfate pentahydrate is called blue vitriol. It has got 5 water molecules. It looks in blue color. These are some of the crystalline materials that have got water of crystallization. Okay, because of the water of crystallization, these crystals show certain physical and chemical properties that are different from the chemicals that have not got water of crystallization. For example, Na2CO3, 10H2O is there, right? By heating it, I can remove this 10H2O. This 10H2O leaves by heating it, right? It gets evaporated. It leaves the crystal structure and becomes vapor and leaves the vessel, right? So Na2CO3 will have certain properties different from washing soda. Okay, the properties can be physical and sometimes chemical also. Okay, let's look at some of them now. Let's take few crystals of copper sulfate. Actually, copper sulfate pentahydrate, you take few crystals of that is in blue color in a test tube and heat it. You have these blue color crystals here and you are heating it. Then what happens? Water leaves the crystals, right? And it may deposit on the surface of the test tube or it may leave the test tube, right? When heated, these crystals are going to lose water. That water is called water of crystallization and become anhydrous CuSO4. The CuSO4 5H2O నుండి 5H2O బయటకు పోయింది అనుకోండి, వాట్ యూ హ్యావ్ ఈజ్ CuSO4. ఎన్హైడ్రస్ అని ఎందుకు అంటున్నాం అంటే దాంట్లో మాయిశ్చర్ అనేది లేదు, హైడ్రస్ అంటే వాటర్ అనేది లేదు అని చెప్తున్నాం. సో ఇట్ టర్న్స్ టు వైట్ కలర్. మనం ఇక్కడ బ్లూ కలర్ క్రిస్టల్స్ తీసుకుని హీట్ చేస్తుంటే ఆఫ్టర్ సమ్ టైమ్ యూ విల్ ఎండ్ అప్ విత్ వైట్ కలర్ క్రిస్టల్స్. దీన్ని బట్టి మనం ఏమని చెప్పొచ్చు? వాటర్ ఆఫ్ హైడ్రేషన్ ఈజ్ గోయింగ్ టు ఎఫెక్ట్ a particular property, that is color of the chemical, right? Water of hydration ఉన్నప్పుడు CuSO4 5H2O is looking in blue color. When that 5H2O is removed, it looks in white color. Understood? CuSO4 5H2O, when you heat it, you are getting CuSO4 and this 5H2O leaving as a vapor. This is the chemical equation for that, right? And if you leave this CuSO4 again for some time, these crystals are going to absorb moisture. గాల్లో ఉన్న మాయిశ్చర్ని అబ్జర్వ్ చేసుకుని they again turn to blue color. Understood? You can remove water of crystallization, but these crystals have a tendency to absorb again the moisture and again get their original crystal chemistry. Understood? Another thing you can see, calcium sulfate dihydrate. This is called gypsum, right? This has got two water molecules along with CaSO4. CaSO4 is calcium sulfate, right? By heating it, I can remove water molecules. But if you can, I have another CaSO4 based crystal that has got half H2O, that is called plaster of Paris or calcium sulfate hemihydrate. Hemihydrate అంటే half water ఉన్నట్టు. Dihydrate 2 water molecules. Pentahydrate 5 water molecules. Decahydrate 10 water molecules, right? So plaster of Paris has got CaSO4 half H2O, meaning hemihydrate it is, right? You see here you have 2 H2O, here you have half H2O. Rest is same, right? Rest is CaSO4. So if I want to get plaster of Paris, I can heat gypsum in a controlled manner. If I heat it, if I supply a lot of heat, all 2 H2O may leave. I don't want to have that. I want to have only 1.5 H2O to leave, such that I'll have plaster of Paris. Gypsum is looking like a rock and plaster of Paris is a soft powdery material, right? On careful heating of gypsum, the gypsum is going to lose water partially to form plaster of Paris. Plaster of Paris is one of the important materials. It is a white powder. It is used by doctors to ఇమ్మొబిలైజ్ బ్రోకెన్ బోన్స్ టు గెట్ దెమ్ హీల్. మనం ఏవైనా బోన్స్ బ్రేక్ అయితే కనుక కదలకుండా కట్టేస్తే హీల్ అవుతాయి, లేకపోతే అది హీల్ అయ్యే ఛాన్స్ లేదు. సో అలా ఇమ్మొబిలైజ్ చేయడం కోసం డాక్టర్స్ ఆర్ గోయింగ్ టు యూజ్ పిఓపి. POP is used in many other, for example, POP based Ganesh idols you get, right? During Ganesh temple you buy. So those are also POP, very soft looking material. POP when mixed with water, it is going to become gypsum, right? POP, this is CaSO4 half H2O. When you have additional 1.5 H2O, it becomes gypsum. Gypsum is a hard material, right? So doctors mix POP with water and make the whatever cast they want to do, so that it becomes gypsum to become hard. Gypsum is a hard material, right? POP when mixed with water, it sets into hard solid mass due to formation of gypsum. Okay, అందువల్ల ఇమ్మొబిలైజ్ అవుతుంది, అంటే బ్రోకెన్ బోన్స్ అవి కదలకుండా ఫిక్స్ అయిపోతుంది అనమాట, అంటే ఇట్ బికమ్స్ లైక్ ఎ రాక్. అర్థమైందా?